Okay, so I start reading as always. On a certain work day, who cares? The rate, that's important. So rate, tons per hour, that's important. Okay, but really, don't get hung up on what they're talking about, really. It's just tons of something. They say unprocessed gravel. This is a keyword, arrives. So we got tons of gravel. So we got a rate at which unprocessed gravel arrives at a gravel processing plant. It's modeled by this equation, so I box that. And again, I want to make sure I do not forget that this is referring to a rate. Is that clear? T is measured in hours, and here's the time interval. That's usually important. Okay, so I've read one sentence. I feel pretty confident about what I read. They're giving me the rate, not the amount, the rate at which gravel arrives. You might do this as well. That means this is an incoming rate. A lot of problems will give an in rate and an out rate. So keep track of that. Anybody have anything you want to talk about so far? Okay? Let's see. At the beginning of the workday, time equals 0, the plant has 500 tons. That's not a rate, that's an amount. So this is an amount of unprocessed gravel, period. So right there, let's keep reading. During the hours of operation, the plant processes gravel at a constant rate again. So we've got a rate, 100 tons per hour. So here's the situation. There's an amount of gravel that's measured in tons. There's an in rate and an out rate. This is the out rate. Because this rate causes the amount to go up, this rate causes the amount to go down. So I could say that A prime is the rate at which gravel comes in, subtract the rate at which gravel goes out. We want to talk about that. This is very common. I've seen problems, you've seen them too. There have been some problems, like the mosquito problem was they said the rate at which the mosquitoes are changing, so they didn't give an in rate and an out rate. They just gave the overall rate at which the mosquitoes change. But it's common to give an in rate and an out rate. So. All right, it says find G prime of 5. Pretty straightforward. They gave me G. I'm supposed to find G prime of 5. That means I need the derivative of this. But it is a calculator problem. So I can just type that on my calculator. So G prime of 5 turned out to be this. So if you have this red box, you should have an equal sign indicating what you're finding. So it should say G prime of 5 equals. But if you have this written on your paper, you get 1 point. Question? Oh, please, Karen.
I forgot the G prime of 5.
I think they'll be lenient because they were only asking for one thing, but it is better to write it. So, anybody else? That was for a good question. Oh, please.
When you do the n prime of t, or sorry, a prime of t, equals t prime, or g of t minus 100, and then just add minus 100
This won't be graded yet. This might show up later, so don't worry about that yet. So that's okay. So did you actually say amount of gravel?
Yeah.
And then you said A prime is equal to just this?
Yeah.
They won't take away points for it, but you might lose points later.
Right, yeah.
Yeah, no worries. Good questions. Good problems. Anybody else? Okay, so keep going. It says using correct units, interpret your answer in the context of the problem. Okay, this is already a rate, so this is a rate of a rate. The units are simple. the amount is measured in tons. That means the rate at which A changes would be tons per hour. That means the next rate, the rate of the rate, has to be units of tons per hour per hour. So to explain this, this is not a rate itself, it's the rate at which gravel arrives. So the rate at which gravel is arriving is decreasing. So this rate, G of T, is going down by this amount, 24.588 tons per hour at time equal 5. You need to have almost word for word what they have here. If you have something different, you can read it to me and I can let you know whether you got the point or not. But it has to be pretty close. Alan?
So I didn't say T equals 5 hours, I just said T equals 5. Is that?
They won't give you the point because you left off the hours. They're very strict. Two couple.
Did you have to say decreasing, or could you just change it by negative?
That's kind of borderline. I have seen cases where they specifically said that they wanted the word decreasing, so I will always advise you to say decreasing or increasing. Okay. Two fellows, was that Ken?
I said I was advised that therefore the gravel is coming in and flowing outside.
Yeah, they don't give you the interpretation.
So I got the interpretation called on, but I got the line wrong. So
Yeah, they'll give you the point. Anybody else? Next one. It says find the total amount of unprocessed gravel that arrives during the hours of operation. Okay, so we're looking for the amount of gravel that arrives. So the fundamental theorem says if you integrate the rate at which gravel is arriving, that integral calculates how much gravel arrived. That's the fundamental theorem. If you integrate the rate at which gravel is arriving, you'll calculate how much gravel arrives. So that's what you do in part B. You simply integrate G over the time period of interest and calculate how much gravel arrives. You have to have the integral written down, always on the test. So if you have what's in the red box, you get 2 points. It has to be what's in the red box. So, question? Please, Terry.
I forgot the.
So you forgot the integral, you only get 1 of 2. Two pebbles for asking them.
So I decided to add 500 to this.
So you'll get 1 point for having the right integral, but you won't get the right answer for it. Because you see your mistake.
Yeah.
Don't worry. Pebbles for Alan.
So it would technically say to use units, so would you need to use units there?
Oh, gotcha. So you lucked out on that one because they didn't specifically say units, but I would always do it just in case.
Yeah.
So you lucked out on that one. Please.
Okay, so if you're always taking a derivative of something, will always be divided by the amount of time?
Yes.
Okay.
So you're asking about the pattern I was showing you here,
Yeah.
right?
So it'll just always be t divided by time?
As long as it's a derivative per dt,
Okay.
which is most common for our class.
Okay. And then also, if you have the absolute value on the next part, is that still okay? I mean,
So
still
you
get
put an
the
absolute value here.
You still get the same answer?
You do get the same answer. Hold on a second. So you're saying you put absolute value here.
Yeah.
Yeah, the word total kind of mess with your brain a little bit because you're thinking of total distance. They'll give it to you because it's mathematically correct, but I would not want to do it in the future. It could cause a mistake. So this is the rate at which gravel is arriving. Therefore, this integral is how much gravel arrived. You don't need the absolute value. The only place I've seen absolute value needed is when we're finding total distance traveled. And that's because velocity can be positive and both negative. This rate, let me pull it up for you. Hey, a smart thing to do on the AP test is in the calculator section, if you always graph what they give you, it helps because you can see in front of you what they're talking about. So, hold on a second. here's the calculator set up. Okay, this is G of T right here. So that's the rate at which gravel is arriving. So that's always positive anyway. So trouble still with you? No? Awesome. Let's go back to here. Okay, is the amount of unprocessed gravel. Part of what they're doing here, everybody, eyes on me, everybody. Okay, this is really common, so feel free to just talk and talk and talk until it really clicks. If you need to make a flashcard to make the memory permanent, do that. It's very common in AP questions to have a situation like this, where there is some amount, okay, and then again there's some rate which causes the amount to grow, and some rate which causes the amount to go down. That's this situation. But they like to ask questions about, like you saw here, they're asking questions about not how much gravel is in the pile, they're asking about how much gravel is arriving. So they kind of forget about how much, the rate at which it's leaving, they forget about the amount that's there. They could easily have some other question which would ask how much gravel left over some time period, in which case they would be ignoring the amount that's there. They would also be ignoring the rate at which gravel comes in. Y'all understand what I'm talking about, like general idea? Now though, they're talking about both the rate at which gravel arrives and the rate at which gravel leaves. But they're ignoring the amount that is there. Because the question says, is the amount of unprocessed gravel increasing or decreasing? We don't really care how much is there. We're just comparing the rate at which gravel comes in to the rate at which gravel leaves to figure out whether the pile is growing or shrinking. You would have a question about that. There's two ways you can think of it. Since A is the amount of gravel, if A prime is positive, this is going up. If A prime is negative, A is going down. So I could simply graph this on my calculator, which I did. So the pink is A prime. And I could simply write that during this time period, A prime is positive, so A is going up. In this time period, A prime is negative, so A is going down. You need me to talk through that again. The other way to look at it is to simply compare the incoming rate to the outgoing rate. When the incoming rate is greater than the outgoing rate, the pile is going to grow, and vice versa. So you could also look at the blue and the black. The blue is the rate at which gravel arrives, the black is the rate at which gravel is hauled away. So here's what I wrote. Let's see. Part C. Is the amount of unprocessed gravel in the plant increasing or decreasing at time equal 5 hours? Show the work that leads to your answer. Okay, I would probably go with, I already told them that A was the amount of gravel. I already told them that A prime was this. So I don't have to rewrite it. And then I can just simply write at T equal 5 hours, always using units. A prime of T, so A prime of 5 is equal to, and I can go find that on my calculator. Oh, wait a minute. Yeah, time equal 5. So go back to here. I go trace, go down to the pink, choose time equal 5, and I get 1.859 negative. Back here, make sure to put in the units. That would be tons per hour. So the gravel pile is going down by this rate. Is the amount of unprocessed gravel increasing or decreasing? Definitely decreasing. So A of T, which is the amount of gravel, is decreasing at T equal 5 hours. So I've shown the work, I've got a good explanation, I get 2 points. There are other ways you can get the 2 points on this one, so if you're uncertain, just ask and I'll check it out.
So I just found, like, normal G of 5, and it was 98.141. And then I said, since it's less than 100 and 100 is the outrate and it's decreasing because there's more gravel leaving.
2 points, perfect.
I didn't create an A prime of 5, and I just said D of 5 minus, well, minus 100 equals that negative number, and then I gave an explanation of that.
2 points, yep. Please.
On the concern about the hours,
You're probably okay on that one because they didn't say you had to have all these correct units and stuff, so they forgive you for that one. Two trouble?
So if you wrote down the wrong, number to like A prime of 5, but you still got that it was decreasing?
I think they'll give you one of the two.
Okay.
Because they'll identify that your logic is correct, they'll notice you made that mistake as you were doing this. Two troubles? Anybody else? Next one. What is the maximum amount of unprocessed gravel at the plant during the hours of operation? So that's a min-max problem. So I remember the min-max theorem. So I'm looking for the max of A. So A will be greatest at the beginning of A, the end of A, or any critical points of A. Well, I already figured out here, since the pink is A prime, that A only has one critical point, and that's here. So I would find that time on my calculator. Any questions so far? So back here, I would be thinking, okay, A is greatest at the beginning of A, the end of A, or any critical points. I would remember that I need to find where A prime is equal to 0. So A prime is equal to 0 at a value of T. Using my calculator, I find this number here, 4.923. Question?
They also give you
Oh. Do you need the number?
after you get the
Oh, yeah, thank you. You're just one step better.
Oh.
Don't worry. So A prime is equal to 0 this time. So then it's, Annalise said, we already know that the amount of gravel at time 0 is 5. Is that what you meant?
Yeah.
Don't worry. So the amount of gravel at time 0 is 500. I need to find the amount of gravel at that time. So using the fundamental theorem, I take the 500, add that to the total amount by which the gravel will change during this time period. Make sure you're saving the 4.923. So doing the integral, I would get this value, 635.376. Then I go find the amount of gravel at time end of the day, which is 8. So 525.551. Read it again just to make sure I'm not missing something. What is the maximum amount of gravel? So now I've got it. So A of T is greatest. This is the maximum amount of gravel. So I'll look for rounding. That sometimes is a thing. So I got 635.376 tons. Follow-up questions from anyone? Please.
So I didn't specifically find the endpoint because I justified you were saying from 0 to A, D of T is greater than F of T, and from A to 8, D of T is less than F of T, so I knew that so by the time it got to 8, it was decreasing. So
Yeah, you do okay on that. Totally. That's just a different way of justifying it. So this way is valid. What you said was perfect. So, and then you did list this as the time. You're fine. Good point. Please.
So at the very bottom, you said A of T is greatest at that, or at that amount. Is that the same as writing like at time equals 4.923?
It would be as long as you had listed up here. You have to have the units. So just read exactly what you, so do you have this stuff here, Maddie?
Well, no, I just had a question, because I just messed up all this one.
That's okay. If you don't have these numbers, you won't get this point, because they're asking for what is the maximum amount, not the time when the amount is greatest. So you've got to have listed the maximum amount. Is that your question? She coupled? Anybody else? Well, please.
So I don't have the part in red, but I got everything else.
You have everything I have in green. I think it's best to mention this because they are asking for you to justify your answer, and they're often looking for this, but I still think they'll give you the three because they'll see that you found it. I think you're okay. Anybody else? Well, please, Zach.
Yeah, so if you have like the word that counts for justification, does it, or does that count for justification?
Yeah, the word here is the justification. Well, really, the justification in this sense is all based on the min-max theorem. So the min-max theorem says A will be greatest at the beginning of A, the end of A, or at any critical point in between. So to justify, I have to find, well, one way to justify is to find all three amounts.
Yeah.
So if you have these two lines, you do have the proper justification. Is that your question?
Yeah.
Covered. Anybody else? Well, next one. So that's the end of number 1.